Welcome everybody who's here tonight, and welcome all the people on live stream. I'm Robert, and I'm talking about IMO navigates the age of alternative marine fuels. So you can see the decarbonisation and zero GHG emissions, full speed ahead. IMO telegraphs. So this report shows some of the changes that are quickly taking place, complying with the new climate change regulations. Hydrogen ammonia underway, and there we see the landing ferry. They're looking at hydrogen power and clean air. That's been in for a few years, and here we are with the greenhouse strategy. IMO, following the Paris Treaty, 1.5 degrees compared to pre-industrial levels. The clean energy IMO carbon intensity is to reduce carbon by 40% by 2030, 70% by 2050 compared to 2008. And the revision this year, only this month or last month, 30% by 2030, 80% by 2040, and 0 at 2050. That's put a lot of pressure on the industry. So then new ships need to have a design index and an energy efficiency plan and a measurement plan. That's the diagram. It shows fuel oil collection system, CO2 intensity indicator, and then the operational carbon intensity plan, which has to be certified by a surveyor and submitted to IMO, and the ships will get a rating next year from A to D. A is the best, D is the worst, and they'll have to put plans in to make sure they meet the next target within 3 years. So there we go. In terms of ships over 5,000 gross tons, CO2 per deadweight ton for bulk ships, per passenger for cruise ships, passenger ships, and per container for container ships. So there's a control center, one of the ship management companies in India. And we get on to the energy saving devices here. We can see hydrodynamic is a big measure that ships can save energy. That's the hull, propeller, and appendages. And there we see on the left a kite, which is becoming popular with slow ships. But that looks a bit fast to me, but still flying a kite. That is fuel savings. Every energy efficiency measure means fuel savings and less emissions. So energy efficiency is the number one fuel, if you like, as described by the International Energy Organization. The first fuel is energy efficiency. And the best energy efficiency is obtained if something is turned off, because it's not using any. So when I go around and look at plants and equipment, if I see lights or something running that shouldn't be running and doesn't need to be running, well, why not turn it off? Or if it needs to be on standby, maybe just have it on standby. Set it up to consume less energy. So these are simple things. Here we see a ship's hazard pod. used, very popular on cruise ships and ferries because it's maneuverability. They can turn the ships without tugs. It can steer and propel a ship, and the power plant is underwater, so it's electric propulsion. Save up to 20%. There's a new P&O ferry, and there it has azipods and many other features. There we go. They've got a power management system to close down parts of the ship not in use, particularly the car decks and cargo places that are not being used. And they'll be set back to emergency or standby conditions, so that they're available if they're needed. But generally, they're turned off when they're not needed, which is a good energy saving measure. Batteries to replace engines when they're in port. They can plug into shore power when it's available. And this one is available at Dover. So that's, and Southampton, or with other major ports in the world, Rotterdam, and many of the major ports now have green power. And but green power or any power is better than fuel for energy saving. Here we can see some other measures. Sail is a very popular, particularly with the French. There we have the CGM ship with a bow shield, and then you've got sailing container ship there. That's another very popular one, or very efficient measure is to have air bubble lubrication, so the ship can have air supply underwater, and it's microscopic. It's riding on a microscopic layer of bubbles, which reduces the energy required by the engines. It's a promising technology. There it is, how it works. Micro-sized bubbles. There we have wind-assisted rotor sails, and they're very popular. The crew love them because they understand sails. It's something they can find out about and very interested in. And the ship was built in Poland recently, and it's got the rotor sails. The captain, the crew was so keen, they want to learn every detail, how they work. And when the wind blows across the ship, it propels. The rotors are turning with the low power, low voltage power. And when the wind blows across, it gets a force forward, which propels the ship, assists the engines. And so that's a very good energy saving measure. And it can be 5 to 25%, depending on the wind and the angle of the wind. And when the captain plots his course, he's watching where the weather is and where the wind is, so he can go a few more miles to save more fuel. There's one SC connector. There, the rotor sails are bent back there. They can be put up and down to go under bridges and low-hanging power lines in the various ports the ship goes to. So top speed on rotor sails is 19.7 knots. And under certain conditions, they can run completely on sails. And other times, just wind assist, or if they can leave them down if they want to. There we have another big one. That's 74,000 tons with the rotor sails. It's the world's shortest, the railroad MV Delphine. It operates around Europe from Spain to Sweden and Ireland. can take any kind of cargo, containers, cars, people, or I'm not sure about people. I think it's a cargo ship. I'm not sure about people on that one. Anyway, it's very effective, very energy efficient. Here we've got the Melton. France is very big into the sailing part of the industry. They're retractable sails, and it's a container ship, and they can be pulled right back, so they're free, so the decks are clear for working cargo, and the bridge is forward for visibility. There's another sailor ship. That's the kind of I can't see the name right now. It's a bit, but that's another one that's tier 3. It's LNG propulsion as well. Now, LNG, the seafarers were badly damaged or psychologically during the COVID period when they couldn't get ashore very easily. They needed vaccination. Some were kept on board for over a year or longer. And the suicide rate among seafarers during that period was very high, as much as 4 to 1 compared to people on land. So they were very stressed, and they haven't really got over that yet. And now they're facing another big challenge to cope with the new technology. So they like the sails, but they not so keen on the new gases that are coming in. Here we see the Corona utility. It's a coal carrier, runs to Australia out of Newcastle to Japan, and you can see there it's got carbon capture, LNG with carbon capture, and sea kite assist. 50% reduction in CO2 by 2030. They're targeting 40%. There's North Shipping. They won an award for their. There we are about it was hydrogen. It's prepared for hydrogen and runs up and down the Norwegian coast. And we can see hydrogen for short sea vessels is a fuel of the future, because hydrogen is zero emissions, got zero GST, zero CO2, and they can use all the, as well as the hydrogen, they maximize the efficiency in every other way they can. Battery packs going up and down the Norwegian coast, they can plug into green power, that's hydro. So they're set up for that along the Norwegian coast. That's that's an IMO diagram giving various measures that can be made in the economical solutions. Now here's another one using solar panels. This is a ship, the Emerald Ace. It's a regular caller at Australia, and it's got battery power on the top. With battery power. The batteries are inside, but the solar power is on top. And it's got a hybrid fuel system, digitization systems, large capacity batteries, and they can. That they don't need any shore power import. They save enough energy from the sea to use all the import requirements, and they can also use them at sea to reduce power on the main engines. So that's very economical. So they're looking, the industry, different owners, looking at different chip types, looking at different technologies. There's a whole range of technologies. And there she is, the Emerald Ace. There's another hydrogen carrier that's built for the Australian liquid hydrogen trade. Between that's a Victoria to Japan. That's a prototype ship, and it's diesel because they haven't got the refueling facilities in Japan to go to refuel there. They're taking the hydrogen, liquid hydrogen to Japan. They can't give it back, or they don't want to give it back to run the ship. So eventually the bigger ships will be full hydrogen, and that'll be totally zero emissions. And here's the first. It's Stena line. That's the line at the top is a bit in the way there, but it's methanol, and they're running the ship on methanol, and they lengthened it. And that's another way to get more capacity for the same power. They lengthened the ship by 30 meters, and they get more cargo, more capacity, more passengers without an increase of power. And that's another energy efficiency measure, is to lengthen the ship. So there's so many different ways that things can be improved at sea. But seafarers are being left behind because there was a survey done by DNV, 500 and charity in Singapore. 500 seafarers were surveyed, and they were asked about would they be happy to work on these modern ships, and 87% said they need further training or full training. So only 13% were happy to work on the new generation ships. Obviously, people that have grown up on those, they're the company ships, people have been promoted and trained, but generally across the industry, that's a huge deficit, and it's a big problem. We're getting to the point where we've got the technology coming, but we haven't got the people to run it, and that's something that's being overlooked or not addressed sufficiently. And people don't seem to be listening to the feedback from seafarers. And I think it's time we started to look at them and collaborated together with all the people involved, universities, owners, surveyors, the crew, operators, ships, seafarers, everybody involved should get together and do something about this. The training on board, the best way, according to DNV, and I agree with, is to first train the senior officers, like the captain and the chief officer and the chief engineer and second engineer. Train the first officers fully first, and then gradually work down the line and have onboard training, and with assisted by videos, films, and of course training ashore. Training in the universities and colleges is very important to know all the basics, and things that could go wrong with a ship. In the airline industry, they train pilots in things that could go wrong, and they have plans. If they lose an engine, something happens, a wing part of whatever goes wrong, they've got a plan to deal with it, and that's what we need in the marine industry for the new technologies. Here's the first LNG container ship in Hawaii. It's exceeded the design experts by over 28%. So they've MAN, B&W engines, auxiliaries. It's LNG powered, and it's run entirely on LNG from day one. And they refuel it in Long Beach, California, from trucks, from cryogenic trucks. And they on the aft end of the ship, they've got the tanks on the deck there. You can see that white section on the deck. That's LNG for powering the ship, stored there. And there she is. And they've got, they claim they've made zero emissions by, made up the difference by buying credits from greening the forests in Hawaii. So that's one measure that's contributed to get the rating. But the 500,000 trees program, they launched the program, and they're keeping it going. They're putting a contribution in for every car they carry on their car carrier in the same company. There's Australia is very big in this class of vessel, and we're building the world's largest electric-powered ferry. It's to operate between Buenos Aires and Montevideo. There she is. That's a design, and that's what she'll look like. And LNG, but she was designed for LNG, but the owners have asked for batteries. So Uruguay owners, so they're now redesigning it for batteries. There's another one built. It's another Australian build, 35-knot passenger ferry for the Sweden to Gotland Island service. So this is an area where Australia has excelled in shipbuilding, is these aluminium catamarans and ferries. And that's another example. 1,900 passengers, 600 cars. That's that was the first successful diesel-electric hybrid. That was jumboized. You can see they put 30 meters into it, and you can see the increase in cargo capacity in vehicles and people. And it's named after Princess Benedicte of Denmark, younger sister of the Queen of Denmark. And there's another, the first LNG ferry for Canada, the Vancouver area, the Salish Heron. And that's one of the biggest ferry companies in the world. There's the artist. What he's done is designed the hull, birds, the Salish heron, the heron, the bird in the local area of Vancouver, and there he is. And that's something, gives the native people of the area something to be proud of, and also promotes the aquaculture around the area, and it's of interest to everybody. That, and Maynard Johnny picks the long neck, wingtail and feathers of the talon of the great blue heron found at Salish, British Columbia. There's the first fully electric tug for the Auckland ports, the Sparky, named after the electrician at sea. Electrician is commonly known as a Sparky, and there they can do 2 departures of a large ship and fast charging between. They've got azimuth thrusters and Tier 3 generators. They've got a generator. They can do transit voyages from port to port which is diesel, but most of the time they're fully electric. Operating cost of the electric, the owners estimate it's 1/3 of a diesel tug. And it's cloud-based optimizing systems. There's another example of Rolls-Royce, Snyder propellers, and dynamic engine control, safety systems. It's an inland ferry between Switzerland and Austria. There's another one in New York, famous Staten Island ferry that's double-ended. To save power, it doesn't have to turn, and that saves power, of course, and it's got the azimuth thrusters again. So efficient maneuvering, less dock and undock. Everything counts. Their methanol's winning over hydrogen for now, but the methanol has a few problems. Running over ammonia, so methanol's running over hydrogen for now. Ammonia is highly toxic, and these are issues that seafarers are afraid about. But what we found is when they're trained, then they know what to do, how to play safe, and what to check and not to check. Once they understand it, the fear goes away. They're comfortable, and that's what's happened. LNG carriers out of Australia, I'm told by Lloyd Surveyor, have the lowest accident rate of any kind of ship, and that's because I believe the crew are so well trained and understand the system. So training is a vital part of seafarer. Seafarers, they're the people who operate the ships. If they don't know what they're doing, you can have more accidents. And the recent report I read from DNV is that there's the number of accidents now is 55% more accidents in machinery failures with new technology than what they had before. So there's obviously new technology, there's a learning curve of the technology, but there needs to be a learning curve of the seafarers as well, in parallel with the technology. If they're upfront operating it. This is something I'm very passionate about, that they should be not neglected the way they have been. So there we are now. There's another hydrogen carrier. This is Australian compressed hydrogen. You can carry the hydrogen compressed as a gas or as a liquid. But if you have it as a liquid, it's minus 253 degrees centigrade, which is cryogenic, very expensive to keep it liquefied and keep it. If you carry it as gas, it's cheaper. And there is a big gas carrier, 26,000 cubic meters there at 25 bar pressure. It's designed, it's not built yet, but it's designed for the Provis Energy. And then after that, there's a bigger one they've got to service the needs of Singapore and the Asian market. So Australia is becoming one of the world's major producers of hydrogen, and that's been ABS approved for compressed green hydrogen. It's 120 cubic meters of hydrogen gas. It's hybrid electric drive, dual fuel, LNG, biogas and ethane, allowing fuel cells to upscale to meet power needs. Now the fuel cells, that's another thing seafarers are afraid of, is fuel cells. They don't understand electrolyzers and fuel cells. So not all seafarers, but the majority. It's a green hydrogen market. So Australia's, for the future, is coming. There's a hydrogen fuel cell pusher tug in service in Europe from Amsterdam and upriver. There we can see on this side I've shown green electricity can be plugged into in port, and that's something that I believe Australia should be looking at to provide these supplies at the major ports, particularly so ships can not emit no emissions in port and get along with electricity in port. So we've got the sail assists, mechanical solutions like heat recovery, efficient insulation, everything that can be improved with efficiency is being looked at on ships, and it's really a cost-effective. If it's too expensive, obviously you need to, owners obviously look at the cost of the implementing the new energy and against the benefit. So the cost benefit is very important. And there's the Maersk. They've got methanol ships on order, and they've got their first ship delivered now, and it's on its maiden voyage, or might have even completed it by now, between Korea and Europe. And on the waypoints, they've had energy bunkering along the waypoints, because methanol, all the gas fuels occupy more space. And so the space that was occupied by diesel and heavy fuels, now much more space is needed, up to 4 times for hydrogen, about 2.6 for methanol, I think it is. And so that's a big issue. And there's ammonia bunkering ship being planned, conceptual study. There's ammonia dual fuel. She's ammonia ready and waiting for the ammonia. And there's another ammonia ship there, which is being built by Mitsubishi Heavy Industries in Japan. So there we got 2-stroke engines, dual fuel. With the dual fuel, they can have one fuel and another fuel, or ammonia. The characteristics of ammonia, it needs a pilot fuel to get it started, and it's safer than hydrogen, of course. Hydrogen is explosive at any temperature, but ammonia is safer, but not completely safe, and but very toxic, and that's a big concern. But it can be overcome with training. Seafarers, once they're trained, they know what to do, and onboard training is very important, as well as institutional training, videos, manuals, and so on. And there she is, built by Mitsubishi. There's the Orient Express. It's a rigged cruise ship, LNG power and cruise. There's inland container ship, diesel to hydrogen electric. There she is, after the hydrogen, before and after the hydrogen electric. So the new fuels are coming. Major problem is we haven't got the infrastructure the bunkering facilities around the world for the ammonia, hydrogen. So what Maersk have done, they've focused on methanol, which is available generally, and I can see by reading all of the articles, they can see one by one, they've got suppliers, the various points. So they've got these methanol ships. So that that'll do, will encourage the infrastructure to get built, because now there's a market for the infrastructure. So what comes first, the market or the product? I think it's chicken before the egg. So situation in the vernacular. So there's a hydrogen fuel cell gas electric ferry for San Francisco Bay. She's built in Portland, Oregon, Portland, not Portland, Oregon, Bellingham, Oregon, Bellingham. What's the name? Anyway, Bellingham, up near the Tasmanian border. Now, the reskilling of seafarers, all the reading I'm doing and what I'm hearing, it's very important. And seafarers want to be reskilled, or they're leaving the industry. A lot of seafarers left during and after the COVID, never come back. Now, a lot of them are staying away because of the fears of the new technologies that they don't know much about, and also the pay and conditions are so poor that they can get better jobs ashore. So this is, everybody concerned needs to seriously address this issue of seafarer training. The unions in Australia, the Maritime Union, the Engineers Union, and the Seamen's Union, they had a meeting recently, and they just to survey how many seafarers there were, and there's under training, and they found that only 1/3 of the seafarers under training could get training berths on the ships. So training berths have been cut out. So the commercial imperatives are put before common sense when it comes to seafarer training. So I think this is the most urgent problem to be addressed by all levels of authorities and anyone who can help. And so if only a third, what do? They go and get a job somewhere else. And at the same meeting, they found out that a small number of seafarers got berths on overseas ships at $50 a month. And to get their certificates of competency, I think that's cruel. But anyway, that's the way the world is. We're putting commercial imperatives before common sense and reaching the objectives. Technically, we can do it, but commercially, we need to get a balance between commercial and regulatory. And what I think is that it should be mandated for ships to take trainees or cadets, and also encourage onboard training as well as institutional training. There's harmony of the seas. Most of these ships have been built as energy efficiency. They can, as a big passenger ship, the hotel load is about 35%, whereas on a cargo ship, it's probably about 5% for the crew services and non-propulsion. 35% is normal for a passenger ship. So that's energy efficiency in that section is equivalent to a hotel ashore. And we know a lot about energy efficient hotels, especially in Australia. There she is, harmony of the seas. There's a Disney ship. They got bow thrusters. There's Australian exhibition ship. It's got the Ulstein bow thruster. 12 knot surface speed, cutting edge electrical systems. That's Australian owned, but it's running overseas. Full carbon neutrality was achieved by adding carbon credit offsets from a wind farm after everything I did on the ship. Slow speed is one method. There was a rule of thumb when I was at sea, and I think it's general now. The fuel consumption varies as the cube of the speed. So the faster you go, the more fuel you use. As you slow down, you have a big reduction in speed. And reports I've recently heard is for 10% drop in speed, there's a 27% drop in fuel consumption. So ships slowing down is one way to save energy. And there's the Savannah. This is a nuclear ship that was built in the 60s, built 1961, and it was very successful and very safe. But eventually it went out of service because it was uncompetitive. They had to have 123 crew. They had to have nuclear specialists ashore. So it was uncompetitive, but nuclear is possibly a future fuel down the track, but it's not, it would be very over expensive now, but as a nuclear separate from the main, that's a submarine just to lay out showing the nuclear part and the engine part. There's, with new ships, there's an example of a new one where they're using thorium, which is less radioactive than uranium, and clean power, small size. So that's an experimental ship, but there she is, the Thor for thorium. But it's a prototype under trial, I could say. There's the two examples of nuclear power ships. The US Navy has an excellent safety record, and it's been attributed to the high level of standardization and maintenance and the high quality of the Navy's training. Now, that's why I'm harking back to the training for the seafarers, so important. There's a Russian commercial icebreaker, so the technology is there. When we're ready for it, it was used in the northern waters of Russia, and refuels about once every 10 years. So it's the technology's there, the training there's. Now we've got power station ships. Power station ships, there's South Africa. Due to the, they have outages of about 12 hours a day, every day, somewhere in the South African network, complete outages. And South Africa is the most industrialized country in Africa. And they have power outages. So they brought this ship, but South Africa wouldn't agree to have it because they thought it was an environmental hazard to the ecosystem. More important, so the next country up, Mozambique, it's moored now off Mozambique, and it supplies power to South Africa via Mozambique, also supplies power to Zimbabwe and Zambia. So it's a stopgap between permanent, but so we can get power to places and green power by innovative means, and this is one means. There's an offshore production vessel. That's off Northwest Australia. We're one of the, I believe we're one of the world's second biggest exporter of LNG. But the countries, we need these gases for marine propulsion, if nothing else. If we go completely off carbon, we can't, it's just not a practical to achieve it. The technology is there, but the expense, the cost, and the infrastructure needed is huge. So there's your loads at sea, gas carriers. It's a production plant. And there's a nuclear power station floating. It's running in Russia to replace a 1940s coal power station. And that had a lot of opposition from the environmental groups. Greenpeace called it the nuclear Titanic. But the power company claims it's clean, green, and stable. So there it is, supplying power to that part of eastern Siberia, which is the northernmost city in that country. So green fuels, hydrogen, ammonia, drop-in fuels, biodiesel. Biodiesel is a good drop-in fuel, but the supply, it's not a good long-term alternative because the amount needed for seafaring alone is huge. And there's some of the drop-in fuels are not suitable, they damage the engines. So if you're using green fuels, this kind of fuel, you should check with the engine makers and make sure that it's safe and proper to use. And also seafarers need to be trained. Liquid hydrogen is coming in the longer term, and ammonia, because the infrastructure is just not there yet for these fuels. Energy efficiency is the first and biggest way to make quick changes for the fuel-saving energy, and also for emission-saving. So we've got uncharted waters, sailing too far too quickly, but it needs to be addressed. So there's various energy efficiency improvement include dynamic design of ships. There's the Naval Architects Department, hull and assist appendages, propellers, wave making, windage, smooth polished hulls, air lubrication, sail assist, technologies, eco-navigation, digital assist, AI assist, sea state water temperature changes, weather tides, current trim. All these things are being implemented gradually or quickly, depending on the different ship owners, energy storage, insulation, efficiency, and the culture on board is so important. We need team cultures on board. And I've sailed on ships, and the happiest ships are the most productive ships and the safest ships to sail on, that from my own experience. And so I would suggest that to the industry to encourage the efficient and culture on board, work as a team, listen to feedback from seafarers because they see things and act on what is worthwhile feedback. Electric power is a leading green option for limited distance because the batteries for big long haul ships would be too big. They take up too much space. Nuclear power, it's expensive and it's coming. And so there's my message. Move ahead with the new technology. It's here, it's coming. We need well-trained, competent, experienced seafarers supported by skilled land-based expertise They're hard to replace. So all new entrants must have a pathway to a career in the industry. Otherwise, they won't be here, so especially associated with the new fuels and use of digital technology. So the valued personnel, capacity to take charge when things go wrong, fix problems, save lives, property, and the environment when things go wrong. The investment in people is vital for success. Thank you.
Don't go anywhere. Thank you very much, Robert. That was very interesting. I particularly enjoyed seeing all those photographs of ships.
Yeah.
We've got time for questions, but before anyone in the auditorium asks, we should have a question number one. Which one are we going for here? And the chat.
I may have misunderstood.
From, Martin Shaw. Martin, are you online?
Yes, indeed I am. Yeah.
Oh, Martin is the current president of IMarEST. And please ask your first question, Martin.
Okay, just first of all, thank you very much for inviting me to ask the first question. Particularly since I spent a reasonable chunk of the 1990s based in Melbourne in Australia. I've rearranged my office so that some of the pictures in the background are Australian relevant. So you'll see one of the first LNG carriers out of
Excuse me, can you repeat the question? I'm not hearing it.
Sorry?
We're just trying to adjust the volume here, Martin. You're coming through very slow.
No, I'm just in the picture. You worry about the volume.
Oh, okay. Please continue, Martin.
Yeah. So yes. Well, thanks very much for the invitation. I'll sort of try and speed things up a little bit for you. Thanks to Robert for his interesting run through all the various options that we face. I think it's fair to say that there's a number of options that are sort of independent of the shore, things like sales and the likes of that, which depend on training, and some that are dependent on the shore. And the chicken and the egg analogy that Robert used is one that they've found in the LNG fueled ships sort of business as well, that you don't build a bunker network without customers. You don't build a ship for a fuel without a bunker network. So so to me, there's design, there's supply, and there is the issue of how much it's going to cost to do all this, which I think people are talking about $3.5 trillion for ships and about 20 trillion ashore. And I guess the question I was going to ask was, what place do you see for learned societies such as RINA and IMarEST in helping this transition and moving us towards the new clean zero future? I mean, my view is that environmentalists can dream of a carbon zero, but it's engineers that are going to have to build it. So how can our respective organizations deliver a useful result in that?
I'm sorry, can you repeat the question? I can't pick it up.
Yeah, we got a problem here with our sound, Martin, but I'm going to repeat the question as I think I heard it. He's asking what do you see IMarEST and RINA, how can they contribute, or what can they do to advance what you've just been talking about?
I think IMarEST and RINA, particularly IMarEST, has got access to the IMO. I think we should have a voice in the IMO, a voice in every place that IMarEST has a voice, and do what we can to bring the various parties together and agree on a solution forward. Certainly, articles can be written and meetings can be held. I think IMO and other ship owner bodies and other related organizations are the place to start.